I am Dr.P.Ponesakki, Associate Professor, Department of Aeronautical Engineering, PSN College of Engineering and Technology, Tirunelveli. Now I am discussing about the unconventional machining process. Okay. First one, classification of non-traditional machining. So non-traditional machining process is three types of processes there. First one is mechanical process, then second one thermal process, then third one chemical and electrochemical process. So various processes in mechanical type. First one is USM, then USM means ultrasonic machining process, then water jet machining process, then abrasive water jet machining process. Then thermal process method is, first one is EDM, then EBM, then LBM, then IBM, then BBM. Then electrochemical method is CHM, DCM, ECM process is there. Then first one is mechanical machining process. So what is going to be mechanical machining process? So mechanical process means first one is ultrasonic machining process. We have to discuss about it. So ultrasonic machining and water jet machining are typical examples of single actions mechanical non-traditional machining process. Then the machining medium is solid grain suspended in an abrasive slurry in the former, while a fluid is employed in the water jet machining process. The introduction of abrasive to the fluid jet enhances the machining efficiency and is known as abrasive water jet machining. Similar case happens when ice particles are introduced as in jet machining process. Then thermal machining process. Thermal machining removes material by melting or vaporization the workpiece materials. Then many secondary phenomena occur during machining, such as micrograin formation of heat affected zones. The source of heat cooled by plasma as during EDM and BBM or electrons in EBM ions etc. So chemical and electrochemical machining process is a chemical milling and photochemical machinings or photochemical blanking or use chemical distillation action to remove the machining alloys through ions in, and electrochemical machining uses the electrochemical distillation ways to remove the machining elements using ion transfer in an electrolytic cell. Then next one, water jet cutting. The water jet cutting as hydrodynamic machining process you have to use a fine high pressure, high velocity of water directed at the work surface to case cutting of the work. Then abrasive jet machining in AGM, the material removal takes place due to impingement of the fine abrasive particles. The abrasive particles are typically of 0.025 mm diameter and the air discharged at a pressure of several atmospheres. Then ultrasonic machining. The basic ultrasonic machining process involves a tool made up of ductile and through materials vibrating with a low amplitude and very high frequency and continuous flow of an abrasive slurry in the small gap between the tool and the workpiece. The tool is gradually fed with an uniform force. The impact of the hard abrasive grains force. The impact of the hard abrasive grains fracture the hard and brittle work surface, resulting in the removal of the work material in the form of small wear particles. Tool material being through a ductile wear out at a much slow rate. Mechanics of material removal. It is a brittle fracture caused by impact of abrasive grains due to tool vibrating and high frequency. So medium is slurry, then abrasive is B4C, SiC and Al2O3 and diamond. The grain size is 100 to 800 is you have to use, while then the vibration frequency amplitude is 15 to 30 kHz and 25 to 100 micrometer. And tool materials are to use is soft steel, then 1.5 for workpiece, then 100 for glass workpiece. Then the gap is 25 to 40 micrometers. Then critical parameters is the frequency, amplitude, then tool material, grain size, abrasive material, feed force, slurry, then slurry viscosity are to base the critical parameters. Then the material application is metals and alloys, then semiconductors, then non-materials, and glass and ceramics, etc. The shape of application is round and irregular holes impressions are to used. Then limitation is very low material loss, then the tool wear, the depth of holes and cavities is small. And the next one, electron beam machining. In electron beam machining is a thermal process. Here a stream of high speed electrons beams on the work surface so that the kinetic energy of electrons is transferred to work producing intensity heating. Depending upon the intensity of heating and workpiece can melt and vaporize. The process of heating by electron beam is used for annealing, welding or metal removal. Then electron beam machining, it is a process of machining materials with the use of a high velocity beam of electrons. The workpiece is held in a vacuum chamber and the electron beam forced on to it magnetically. As the electrons strike the workpiece, their kinetic energy is converted into heat. This concentrated heat raises the temperature of workpiece materials and vaporizes a small amount of heat, resulting in removal of metal from the workpiece. The reason for using a vacuum chamber is that if otherwise the beam electron will, the gas molecules and will sector. Then the main component of the electron beam machine is then electron stream, then magnetic lens, deflection coil, then high vacuum chamber, then optical viewing systems, then anode and cathode, then high voltage cables are used for the main component of the electron beam machining. Then the laser beam machining, So laser beam machining use the light energy from a laser device for the material removal by vaporization. Laser is the term used for the phenomena of the amplification of light by simultaneous emission of radiations. The laser is an optical transducer that converts electrical energy into a high light beams. The energy of the light beam is concentrated not only optically but also with time. Laser beam machining, the setup consists of a stimulating light source, the light flash lamp, and a laser rod. The light radiated from the flash lamp is focused onto the laser rod or laser tube, from where it is reflected and accumulated in the bulb. The light is emitted in the form of a slightly divergent beam. The lens is incorporated suitably in the path of this beam of light, which converges and focuses the light beam on the workpiece to be machined. This concentration of the laser beam on the workpiece melt the work material and vaporize it. It is very costly method and can be employed only when it is not feasible to machine a workpiece through the other methods. Then the main component of the laser beam machining is flash lamp, then laser discharge tube, then partially reflecting mirror, then laser light beam, then lens, then focal length, and the lasers. I have to use it for the main component for the laser beam machining process. Then the ultrasonic machining is the high frequency electric current is sent the ultrasonic oscillator to the ultrasonic transducer. The function of the transducer is to convert this electrical energy into mechanical vibrations. The vibrations show generated of the order of 20 kilohertz to 30 kilohertz. Although the available amplitude usually varies from 15 to 50 micrometer. The transducer is made of a magnitude selective material which is excited by the following high frequency electric current, and this results in the generation of mechanical vibrations. These vibrations are then transmitted to the cutting full with the intermediate connecting parts, such as transducer cone or horn connecting body and tool holders. Slurry or small abrasive particles is forced against the work by means of vibrating tool, removing the workpiece metal in the form of extremely small chips. The grains used are of silicon carbide and aluminum oxide, then boron carbide or diamond dust. This process is suitable only for hard and brittle materials like carbides, glass, ceramics, silicon, then germanium, then titanium, then tungsten, then tool steels and die steels, etc. The vibrating frequency used for the tool is of the order of over 20,000 oscillations a second. Such a high frequency, which is more than the upper limit of audible frequency for human ear, makes the process silent. This makes the tool vibrate in a longitudinal direction. The intermediate part together from what known as the focusing unit and the cutting tool is fastened and its end. The shape of the cutting tool is the same as that of cavity tube produced by it. The slurry formed by the suspension of abrasive grains in a carrier fluid is fed into the machining area by means of a circulating pump. However, in order to keep its temperature low, a suitable cooling system may be incorporated. The main component of the ultrasonic machining process ultrasonic transducer and also ultrasonic oscillators, then feed mechanism, then extension coil, then transducer cone, then connecting body, then tool holder, then cutting tool, then abrasive slurry, and abrasive slurry pump reservoirs also used for the main component of the ultrasonic machining process. Then plasma machining process. What is meant by plasma? When gases are heated to temperature above 5500 degrees Celsius, they are ionized and exit in the form a mixture of free electrons, positively charged ions and natural atoms. This mixture is termed as plasma. The temperature of central part of plasma goes high as between 1100 degrees Celsius to 2800 degrees Celsius, where gas is completely ionized. In plasma machining or plasma or cutting, a high velocity jet of this high temperature ionized gas is directed onto the workpiece surface by means of a well designed torch. This jet melts the metal of the workpiece and displaces the molten metal away from its path. The heating of workpiece material is not due to any chemical reactions, but on account of the continuous attack of electrons, which transfers the heat energy of high temperature ionized gas to the work material. This process can therefore be safely used for machining of any metal, including those which can be subjected to chemical reaction. Plasma machining is a main component of the plasma machining. Then electrode, then chamber, then gas mixtures, then arc, then nozzle, then power supply are to used. Then electrochemical machining process. The ECM is an extension of electroplating with some modifications, but in reverse directions. Thus, ECM can be described as a control at atomic level of the workpiece, that is electrically conductive by a shape tool due to flow of high current at relatively low potential difference through an electrolyte, which in quite often water-based natural salt solutions. The main component of this part, electron stream and magnetic lens and deflection coils are to used. Here anode and cathode also used. The vacuum chamber is main parts of in the process. Then mechanical energy based process is abrasive jet machining and water jet machining, then ultrasonic machining process. And the principle of abrasive jet machining is, in abrasive jet machining process, a high speed stream of abrasive particles in mixed with high pressure air or gas are injected through a nozzle workpiece to be machined. The construction of abrasive jet machining is, first one is the gas is entered to the process, then gas will be filtered, then the regulator also fixed in the process. What is the purpose of the pressure regulators? The gas flow enter in the safe pressures. Then it consists of a mixing chamber, then nozzle pressure gauge, then cooper, then filter, then compressor vibrating device, then regulator are to use. The gases used in this process are nitrogen and carbon dioxide or compressed air are to used. The abrasive particle used in this process are aluminum oxide, silicon carbide, then glass powder, then specially prepared sodium bicarbonate. Then aluminum oxide is a general purpose abrasive and it is used in the size of 10,020 microns have been used. Then silicon carbide is used for fast cutting on extremely hard materials. The size used to 20 and 25 microns. The glass powder of diameter of 0.3 to 0.6 mm are used for light polishing and repairing. As the nozzle is subjected to a great degree of abrasion wear, it is made up of hard materials such as tungsten carbide, synthetic shaper, etc. to reduce the wear rate. The nozzle made of tungsten carbide have an average life of 12 to 20 hours. Synthetic spheres nozzle have an average life of 300 hours. And the nozzle tip clearance from work is kept at a distance of 0.25 to 0.75 mm. The abrasive powder feed rate is controlled by the amplitude of the vibration of the mixing chamber. The pressure regulator controls the gas or airflow or pressure. They control the size and shape of cut. Either the workpiece is moved or nozzle moved by a well-designed cam mechanism. The working of abrasive jet machining, dry air or gas enters the compressor through the filter where the pressure of the gas is increased. The pressure of the gas is from 2 kg per centimeter square to 8 kg per centimeter square. In compressed air or high pressure gas is supplied to the mixing chamber through the pipeline. The pipeline carries a regulator to control the air or gas flow and its pressure. The fine abrasive particle are feed through the cooker and feed into the mixing chamber. A regulator is provided to control the flow of abrasive particles. The mixture of abrasive particles and gas flow through the nozzle at a considerable speed. The mixture flow at a speed of 300 meter per second. A vibrator is fixed at the bottom of mixing chamber. When it vibrates, the amplitude of the vibration controls the flow of abrasive particles. Then working of abrasive jet machining, used for machining hard, brittle and non-metallic metal of thin sections. Example, germanium, glass and ceramic and mica. This process is capable of drilling, cutting, then etching and cleaning the surfaces. Then abrasive jet machining differs from sand blasting process in ultrasound. In abrasive jet machining, metal removal with the use of small abrasive particle is done, wherein sand blasting only surface cleaning is done. Then advantages of abrasive jet machining process is suitable for cutting all material. Even diamond can be machined using diamond as an abrasive. There is no heat generation during this process. Thermal damage of the workpiece is avoided. Very thin and brittle material can be cut without any risk of breaking. There is no contact between the workpiece and tool. Low initial investment and a good surface finish. Then the disadvantage of abrasive jet machining process is material removal rate is slow. Then soft metal cannot be machined. Then machining accuracy is poor. Nozzle wear rate is high. Then the abrasive powder used in this process cannot be reused because of decreasing cutting capacity and clogging of the nozzle due to consumptions. There is always a danger of abrasive particles getting embedded in the workpiece. So cleaning is essential after the operation. requires some kind of dust collection system. Application of abrasive jet machining. Machining of hard and brittle materials like quartz, ceramics, glass, fine drilling. Then machining of semiconductors. Then machining of indirect profiles on hard and brittle materials. Then cleaning and polishing of plastics. Then nylon and components. Surface edging and surface preparation. Forcing of the interior surface of the glass tubes. And characteristics of abrasive jet machining is work material is hard and brittle materials are to use like glass and ceramic and mica. Then abrasive material is aluminum oxide, silicon oxide and glass powder are to use. Then size of abrasive is around 25 micrometers and flow rate is 2 to 20 dam per minute. Then medium is carbon dioxide or air or nitrogens. Then velocity of the speed is 125 to 300 meter per second. Then pressure is 2 to 10 kg per centimeter square. The nacelle material is tungsten carbide and synthetic have been used. The life of nacelle is tungsten carbide is 12 to 20 hours and synthetic shaper is 300 hours. The nacelle tip clearance is 0.25 to 15 mm. Tolerance is plus or minus 0.05 mm. Machining operation is drilling, cutting and cleaning. The metal removal rate is dependent upon the following parameters: mass flow rate, abrasive grain size, then gas pressure, then velocity of abrasive particle, then mixing ratio, then nacelle tip clearance. And material removal rate, mass flow rate, at a particular pressure the material removal rate increases with the abrasive flow rate, but after reaching an optimum value the MR metal removal rate decreases with further increase in abrasive flow rate. This is because the mass flow rate of gas or air decreases with the abrasive flow rate. The abrasive grain size is the various abrasive particles is used in abrasive jet machining process are aluminum oxide and silicon carbide and glass powder and prepared sodium bicarbonate. Aluminum oxide is general purposes abrasive and it is used in the size of microns. Then silicon carbide is used for the fast cutting and extremely hard materials. The size used to 20 to 25 microns. Then glass powder of diameter 0.30 to 0.6 mm are used for light polishing and repairing. The general lasers small size are used for good surface finish and precision. Grain size is 50 microns. Metal removal rate, the gas pressure, the metal removal rate increase with the gas or air pressure, and then velocity of abrasive particles, the metal removal rate increase with the increase in velocity abrasive particles. Then mixing ratio is defined as the ratio of mass flow rate of abrasive to the mass flow rate of gas. Mixing ratio is equal to mass flow rate flow is divided by mass flow rate gas. Metal removal rate first increase with the increase of mixing ratio up to certain limit. After that it decreases gradually as the process. Metal removal rate, the nacelle tip clearance or stand-off distance. The distance between the nacelle tip and the workpiece high create influence on the diameter of cut, its shape and size, and also on the rate of metal removal rate. The metal removal rate first increase with the increase of tip clearance from workpiece up to create a limit. After the unchanged for a create a tip clearance decrease gradually. Then the Key of the element in water jet machining is a jet of water. Water jet travels at velocities as high as 900 meter per second, approximately Mach 3. When the water stream strikes a workpiece surface, the erosive force of water removes the material rapidly. The water in this case act like a saw and cut a narrow groove in the workpiece metal. The water jet machining involves directing a high pressure 150 to 1000 megapascal high velocity is 540 to 1400 meter per second water jet faster than the speed of sound to the surface to be machined. The fluid flow rate is typically from 0.5 to 2.551 minute. The kinetic energy of water jet after striking the work surface is reduced to zero. The bulk of kinetic energy of jet is converted into pressure energy. The local pressure caused by the water jet exceeded the strength of the surface being machined. The material from the surface gets. Water is the most common fluid used, but additives such as alcohols, oil products and glycerol are added when the can be dissolved water to improve the fluid. Then equipment. Typical work material involves soft metal, paper, cloth, wood, leather, rubber, plastic. That material is brittle is will surface if it is ductile it will cut well. Water jet machining consists of hydraulic pump, intensifier, accumulator, high pressure tubing, then jet cutting nozzle are to use. In hydraulic pump powered from a 3 kilowatt electric motor supplies oil at the pressure as high as 117 bars. Compressed oil drives a reciprocating plunger pump is have to use. Then hydraulic pump offer complete flexibility for water jet cutting and cleaning application. It also supports single or multiple cutting stations for increased machining productivity. Accept the water at low pressure and examine it through an accumulator and higher pressure of 3800 bar. The intensifier converts the energy from the low pressure hydraulic fluid into ultra pressure water. The hydraulic system provides fluid power to reciprocating machine in the intensifier. The limit switch located at each end of the piston travel signal and the electronic controls are to shift the directional control valve and reverse the piston direction. As one side of the intensifier is in the stroke, the opposite side is generating ultra pressure output. Maintains the continuous flow of the high pressure water at pressure locations. The release on the compressibility of water 12% and 3800 bar in order to maintain a uniform discharge pressure and water jet velocity when the intensifier piston changes direction. And high pressure tubing transports pressurized water to be cutting a typical tube diameter or 6 to 14 mm. The equipment allows for flexible movement of the cutting head. The cutting action is controlled either manually or through a remote control valve specially designed for this purpose. Then jet cutting nozzle. Nozzle provides a water jet stream for optimum cutting of low density soft material that is considered unmachined by conventional method. Nozzles are normally made from synthetic shape. About 200 hours of operation are expected from the nozzle, which becomes damaged by particle of the accumulation of minerals deposit on the or is due to use water hardness. The compact design of the water jet cutting head promotes integration with the motion control system ranging from two axes, either X, Y, table can be used. In process parameters is jet nozzle. The standard distance gap between the jet nozzle 0.1 to 0.3 mm diameter and the workpiece is 2.5 to 6 mm. However, for materials used in printed circuit boards, it may be increased to 13 to 19 mm, but the larger the standoff distance, smaller will be the depth of cut. When cutting fiber reinforced plastic reposo had to use that the typical pressures used are 150 to 1000 megapascal to provide 8 to 8 kilowatt of power. For given nozzle diameter, increase in pressure allows more power to be used the machining process, which in turn increase the depth of the cut. Jet velocity range between 540 to 1400 meter per second. The quality of cutting improve at a higher pressure by winding the diameter of the jet and by lowering the transverse speed. Under such conditions, materials of greater thickness and densities can be used. The workpiece is brittle materials will fracture, will ductile once will cut well. Material thickness range from 0.8 to 25 mm or more. The application is water jet machining is used on metals, paper, cloth, leather, rubber, plastic, food and ceramics. It is a versatile and cost effective cutting process that can be used as an alternative to traditional machining method. It completely eliminates heat affected zone. It is the most flexible and effective cleaning solution available for a variety of industrial needs. In general, the cut surface has sandpaper appearances. Moreover, hardener materials accept better edge finish. Then the drilling is the process drills precision align the shape holes in a variety of materials for which other process such as EDM. Machining of fiber reinforced plastic. In this case, the thermal material damage is negligible, the tool being effectively pointed, accurately cut and contoured. The main drawback is the deflection of the water jet pipe, the fiber. In matrix with produced after machining, the feed rate attainable depends on the surface quality required. Water jet cutting of a 51 mm depth in gradient using two oscillating jets at 275 megapascal during 14 pieces. At a 25.4 mm per second feed rate has been reported by. Moreover, an oscillation nozzle system operating at the same feed rate or pressure of 172 megapascal, the standard of distance adjusted every passes was used to cut a 178 mm depth soldering canvas. During the method, use a large pressure to remove large 3 mm height in 12 mm diameter drill hole in a whole molybdenum chromium steel soft and 15 using 700 bar pressure and flow rate is 27 liter per minute. In this method, fuse are broken off by the impact of water. Using small diameter water jet, a printed circuit board can be cut at a speed that exceeds 8 meter per minute to the accuracy of 0.13 mm. In surface treatment, removing deposit and reduce without toxic chemicals, which eliminates costly cleanup and disposal problems. Surface cleaning of pipes and casting, decoding, finishing, nuclear decontaminations, food industrial cleaning. Then the advantages, it is multi-directional cutting capacity, no heat is produced, cuts can be standard at any location without the need for predicted holes. Then weighting of the workpiece material is minimal. There is no deflection to the rest of the workpiece. The tool does not wear and therefore does not need sharpening. The process is environmentally safe. There is multiple head processing. Simple fixturing eliminates costly and complicated tooling with the reducers. And grinding and polishing are reducing secondary operations cost. It is ideal for rough out material for near need shape. It is ideal for laser reflective materials such as copper and aluminum. It allows more accurate cutting of soft material. It is not suitable for mass production because of high maintenance requirement. Then electron discharge machining process. Sometimes it is referred to as spark machining, spark eroding, burning, die spinning or wear erosion. It's a manufacturing process whereby a desired shape is obtained using electrical discharge. Material is removed from the workpiece by a series of rapidly recurring current discharge between two electrodes. One of the electrodes, tool electrode or tool electrolyte workpiece or electrolyte. As distance between the two electrodes is reduced, the current intensity becomes greater than the strength of the dielectric. This allows current to flow between the two electrodes. This phenomenon is the same as the breakdown of a capacitor. As a result, material is removed from both the electrodes. Once the current flows stop, new liquid dielectric is usually conveyed into the electrolyte zone. Also, after a current flow, a difference of potential between the two electrodes in respect to what was before breakdown, so that a new liquid dielectric breakdown can occur. Then EDM is machining method primarily used for hard metals or those that would be very difficult to machining with traditional techniques. EDM typically work with material that are electrically conductive, although method of machining insulating ceramic with EDM have been proposed. EDM can cut indirect contours or cavities in harness steel without the need for heat treatment of soften and reheaten them. This method can be used with any other metal or metal alloys such as titanium. Also, application of this process is shear polyethylene diamond tools have been quoted. The main component of EDM, electric power supply, dielectric medium, workpiece and tool, and servo control unit. The workpiece and tool are electrically connected to a DC power supply. The current density in the discharge of the channel is of the order 1 lakh an ambient per centimeter square and power density is nearly 500 megawatt by centimeter square. Dielectric slurry is forced through this gap at a pressure of 2 kgf per centimeter square. It is process of metal removal based on the principle of metal removed by and interpreted electric spark discharge between the electrolyte tool and the workpiece. In EDM, a potential difference is applied between the tool and workpiece. Depending upon the applied potential difference and the gap between the tool and workpiece, an electric field will be used. And working principle of EDM is although electrons get accumulated more positive ions and electrons would get generated due to oscillations, the concentrations would be so high at the matter exiting in the channel it would be characteristic of plasma. This is called available motion of electrons. the high-speed electron then imaging on the job and ions to the tool. The kinetic energy of the electrons and ions are impact with the surface of the job. Such, such localized extreme rise in temperature leads to metal removal. The material removal occurs due to instant vaporization of the metal as well as due to melting. The motion metal is not removed completely but only practically. Then electrolyte material should be used such that is you would not undergo much tool wear when it is impinging by positive ions. Thus, the basic characteristics of electrode materials are high electrical conductivity, electrons and could made more essentially, and there is less bulk electrical heating. High thermal conductivity for the same heat load, the low temperature rise will be less due to faster heat conducted to the bulk of the tool and those less tool wear. Now, the normal flow, the practical useful in machining cavity dies where the taper produced using a normal flow mode can be reduced. Jet polishing, then impression polishing,